let's say that's a goat stool. All right, we're measuring it. We have to determine, I don't know, its consistency or something, volume, but we're not going to stuff it into a beaker. We're just going to measure length, width, and height. Forget about width and height. We're looking at length here. Now, so we have this stool. Can you see it? I'm trying to measure its length. I chose that because this is a lot like real life. Even if you're in the lab and you're trying to measure something, it's never nice and straight. It's never. Even if you think you're measuring something nice and straight, if you magnify it, you'll see it's pretty jagged. All right, so everybody can see that the stool extends all the way to where this indicator is. Now, let's talk about that indicator for a minute. When we measure things, we either lay them right next to the measuring device and we compare it, as in liquid in a beaker, red alcohol in a thermometer that creeps up. We compare the thing to the scale. In some situations, it's not possible to lay the thing we're measuring next to the scale, so we use a needle. Can anyone give me an example of a measuring device that uses a needle to measure something that we cannot lay next to the measuring device?
Pressure, like
pressure. Right. When you hook up a pressure meter to your tire and you look at how much air pressure is in the tire. I guess they would call that a barometer of sorts. You can't see the pressure. You can't lay the pressure next to the scale and say, oh, it's about that much. You have to use a secondary indicator, which might be a needle or something. You know, it could be a liquid or something, but often a needle. I'm asking for anything that you might have in your house that has a needle or an arrow on it. Could maybe even be in the car. We already got air pressure. That was a great example from the
gas in a car.
Yeah, the fuel gauge. The fuel gauge on your car usually is a needle that goes from E to F, right? Wait, are those little needles moving around a gauge? Wow. You mean we can't measure time as a substance? We have to have a secondary indicator like a minute hand or a second hand? That's fantastic. Great example. Emmanuel, that's 2 for 2. All right, moving on. The point that I'm trying to make here is sometimes we're able to lay the substance alongside the measuring device and compare it directly. Sometimes we can't. Time, the fuel in your tank, the pressure in your tires, you're not going to lay them next to some stick. You're not going to get out of your car and shove a stick in your tank and pull it out and say it's wet to here. That would be very inconvenient. So we use a secondary indicator, and it's usually a needle next to a graded dial. This material here, as you move from left to right, it corresponds with various lines below it that are marked. And then at some point, this one here, I'm going to draw. We see that there's some substance, or the arrow, either way, this, whether it be the material itself or an indicator of the material, is just beyond this line, but not yet to this line. I like to refer to this space between the two closest lines into which the object or the indicator extends. I like to call that the gap. That's our gap. Now, look down here, and you will see that the substance extends a portion, but not all the way into the gap. The guessed portion. We're guessing it. There's no lines below it to read. There's no lines below it that we can say, oh, it's 7 of those. They don't exist. You can buy a more expensive ruler that is further subdivisions, but even then, you're still going to have to guess between 2 of those close subdivisions. All right. Now, if that's the guessed portion of we're guessing how far into the gap this guessed portion is. Then we have another part here to measure. This portion right here, up to the line, we know exactly how much that is. We know exactly how much the left side of this material is up to this line. But we know also that that substance isn't just that portion. Because we know exactly how much this is, because there are lines that correspond with that portion, we call this what? What do we call this portion over here?
The known.
The known. Very good. The total measurement is equal to the known portion plus the guessed portion. Is anyone not clear on that? That the total measurement of that goat stool is the known portion plus the guessed portion. To get the known portion, you simply look at the numbered lines or you count the lines. You have to use the value of the gap. So let's talk about the gap size. To get the gap size, the gap is going to be determined in the following manner. The gap size, subtract adjacent numbers, 13 minus 12. So we subtract the 2 adjacent numbers. Now that's the distance. That's the distance. If we subtract the 2 adjacent numbers, that is not the gap size. That's this distance right here. If we subtract those 2 numbers, this we have just learned is 1 centimeter. Most likely it's centimeters. In our class, we will use metric lengths. We will not use English standard or something like that. 1 centimeter. So by subtracting 2 adjacent numbers, we get the distance between the 2 numbers, but that's not the gap size. Then you divide by the number of gaps, assuming the gaps are equal. Let's see how many gaps there are down here. We have 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 gaps. Assuming that they're equal gaps, we are back up here now. And then we do a little math. And we get this. 1 gap equals that. Or 1 gap equals 0.1 cm. Any questions about what I just did? Determining the gap size. I subtract 2 adjacent numbers. I divide it by the number of gaps between those 2 adjacent numbers. And that gives me the decimal value of the gap size. Now, you might be thinking, Baytal, this is really stupid because we're dealing metric. Well, if you look at the examples in the slideshow, beakers are not metric. Sometimes they are, sometimes they aren't. Why do we need to stop our known measurement to get that figured out? Because look at this. The known is equal to, and now what we're going to do is we're going to look at this and we see the number 12 next to this tall bar. And then we have these little lines down here, but we now know that the distance between that line and that line is 0.1 centimeter. So we can count by 0.1s. 12.1, 12.2, 12.3. So our known portion is now 12.3. Now again, we've all been using metric rulers since we were children. So this may seem rather insulting, but we're going to apply this technique to a more challenging measuring device in one moment. So we need to add to that the guessed portion. Then that means 12.3 plus, we're going to take the gap size and we're going to ask ourselves, what fraction of that gap size does that material actually cover? What fraction of that gap size does that material actually extend or stick into the gap? But as you heard somebody say earlier, we're not going to use random fractions. Oh, I think it's 1/3. It might be approximately 1/3. We can do better than that. Psychologists have told us that human beings are capable of visually separating spaces into 10 equal parts. All right. So psychologists think that it may be that we are, we have evolved a sense of 10 from our digits on our hands and our feet. Who knows? But they do say that humans are quite capable of mentally subdividing distances and amounts into 10 piles or 10 spaces. So what we're going to do is we're going to use the fraction of tenths. My question to you is, what fraction of this entire gap? In other words, what fraction of the green line is the yellow line?
4/10.
Roberta says 4/10. That is the fraction that we're guessing that the goat stool extends into that gap. But it's not just 4/10. It has to be 4/10 of something. It's 4/10 of or times the gap size, 0.1 centimeter. Total it up by saying this equals 12.3 plus 0.04 centimeters, 0.34 centimeters. Should be stated that the known here is also in centimeters on this particular device. Any questions about that? There's one thing left that I need to cover for you to have all the basics for your lab, but then we're going to go back to our class notes and solve a harder problem, and then I will set you free to do your lab. It's called the uncertainty of the measuring device. This is how I was taught to do it. It's 1/10 of the gap size. That's our uncertainty, and I will tell you now, you and I can differ by 1/10 in terms of our guess of the fraction. Let's see what the uncertainty is. Uncertainty equals 1/10 of 0.1 centimeters. We already calculated. That means the uncertainty of this measuring device is plus or minus 0.01 centimeters. And what that also means is that all measurements of using this device are going to be good to the hundredths place and will be some multiple of the hundredths place. So you'll see all measurements are 0.00, 0.01, 0.02, 0.03, something like that. In other words, it will be something 0.0 something, 2 decimal places. Let's do this one. In order to do this one, I need to determine the known, the gap size, the fraction, total, and uncertainty. We're measuring the yellow liquid in the beaker. And if you got the question right, good for you. That is called the meniscus. When the liquid is curved, and many liquids do curve in containers, what's actually happening is on the sides of the container, the water is electromagnetically climbing up. So we read from the middle. When you have a meniscus, you always read from the middle, whether it's concave like this or convex. If you put mercury in a glass container, you get a convex. It curves upward, but you still read the middle of all liquids. You always read the middle. So what we want to know is what's the volume from the 0 here to here. And we're going to break it down into the knowns, the gap size, the fractions, the total, and the uncertainty. What would you say is the known portion that the liquid passes? What is the mark that is known that the liquid passes?
525.
525 is the known value. It is the last number that the center of the liquid has passed. The center of the liquid has not reached 700. Do not read the edges. That does not count. So 525 is what it has passed. The gap size, let's see.
175.
170. The gap in question is the liquid between the 700 and the 525. So we subtract 700 minus 525, and you do get 175. That is the gap size. If the entire gap, and you can see in red ink or font there, it's labeled, with a bracket, that's the entire gap. What fraction of that entire gap does the liquid extend into that gap?
I said it was 7/10.
Okay, she said 7/10. All right, let me show you another screen. Let's change screens so we can. Here is what I'm asking. Let's take a small slice out of this beaker. Let's take this chunk right here. So this line here is this line here. This line here is this line here. And this line here is the dotted line here. The question that I'm asking is, what fraction of this orange line is this green line? The liquid extends from 5, whatever it was, to here, but the whole gap is all the way up there. So what fraction? Because this is a volume. The gap is a known volume. If I can estimate the fraction that it extends into that known volume, then I multiply that fraction times that known volume, and I will get a fairly good, repeatable estimate of the volume above this line right here. The answer was 7/10. Elizabeth threw that out there, that it's 7/10. Now, I'm going to say 6/10 for a reason, but that would automatically include Elizabeth's answer because I allow her to be 1/10 off of mine. So on a quiz, if she said 7/10 and I'm grading it with 6/10, she gets 100% for that. This is a close-up of the situation. The orange line represents the gap from the last known number to the next line. The green line represents the liquid passing the last marked line, or the last marked line, up to its meniscus. That is the amount we're measuring. My question is, what fraction of the orange line, which we know, is the green line, which we're guessing in tenths? Because, Emmanuel, the orange line is a known volume, but the substance, the liquid, does not go all the way up to that next line. It only goes a portion of the way, so it's only a portion of that volume. By asking ourselves what portion of that full volume is it actually in tenths, we then multiply it by the volume, and we'll get the actual amount that it extends into the gap. So the total, this is what I love about OneNote. Ready? 525 is the known, plus 6/10 times 175. And because it's OneNote, I can just put an equal sign there and forget my calculator. Bam, 630. So my measurement for the volume of that liquid is 630. And if I write that in my answer, I will get it wrong, because there's something else I need to tell you related to the next question, which is the uncertainty.
Is it 1/10 of the gap size?
It is indeed 1/10 of the gap size, and the gap size is 175. We have it written right there. Put an equal sign and ask Mr. Gates. Mr. Gates, please calculate that for me. 17.5. Now, what does that tell me? It tells me that my answers have to have one decimal place, just like the uncertainty. It also tells me that all possible answers will be multiples of that 17.5, meaning they will either have 0.5 in the decimal place or 0.0. So there you go. It's not 630. It's 630.0, because this measuring device can distinguish to the tenths place in chunks worth 5/10. It can go 5/10 or 0/10, 5/10 or 0/10. What am I talking about? I'm talking about if it was 1/10. I'm talking about if it was 1/10, you'd have 17.5. If it was 2/10, you'd have 35.0. If it was 3/10, you would have 52.5, etc., etc. In other words, the ones place is going to either be a 0.5 or a 0.0, and that's how you know how to write your number. You go ahead and calculate it, check your uncertainty, look at the units of the uncertainty, one decimal place, multiples of 0.5. The lab. You're going to measure 6 objects. Not objects. You're going to measure 6 things. You can measure time. You can measure speed. You can measure rotational velocity, RPMs, tachometer stuff. You can measure air pressure. You can measure weight. You can measure volume, length. Anything that you have in your house that is measured with an analog measuring device. That is a device that has lines, either straight lines like on a ruler, or curved lines like on your fuel gauge or your speedometer maybe. Some of you have balances in the bathroom with dials. Some of you have clocks with second hands or minute hands. You're going to measure 6 things from 2 different measuring devices. You're going to break it down by writing in the name of each thing that you're measuring. Then you're going to break down known, fraction, gap size, and total. You cannot use a digital measuring device. You cannot use a digital measuring device. You have to use analog. So that's either a measuring cup for measuring milk for cooking, or it's the clock with a second hand or a minute hand and numbers on it. You're going to use the lab template. So copy this. Okay, we're going to copy this. You're going to create a lab tab with today's date. I'll put today's date, 9-24-20, measuring lab, or something close to that. I'm just going to paste it. Now I got to get rid of the yellow. The instructions clearly state, Do not copy the yellow. So get rid of it. How do I do it? I highlight it. I turn off the highlight, and then I just delete that. If you don't turn off the highlight, when you start typing, it's going to type in yellow. Don't do that. Watch. I get rid of that. I say, this is not supposed to be yellow. But it is because I forgot to turn off the highlight. So let me turn off the highlight. Boom. 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 Got him. All right. So there you go. You are going to fill out all those blanks up there. The problem statement, I'll take you to the problem statement in a minute. Remember, hypothesis is, if then. You write the procedure on the left, you write your observations on the right. However, you can put all of your measurements, your knowns, all of that, rather than clutter up your observation column, you can say something like C, calculation section for the data table. What data table? This data table in today's lesson plan. You grab it. You gotta love the technology. And Jessica. Bam. There it is. Get rid of that because we're not doing length of pencil. I mean, you can if you want, but I'm going to open it up and leave it blank. Get rid of all that fake data. No fake data. Type in under station. You're going to type in the name of each thing that you're measuring. Time, volume of milk, tea, whatever. All right. You're going to fill it in for each station. For observations, make sure you put in the observation column. Make sure you put in the observation column what the units of each measurement is. You don't have to write 100 times. You could say, for station 2, I'm doing the volume of iced tea or tea. That would be in cups, or that would be in ounces, or that would be in milliliters, whatever you're measuring. If you're using the bathroom scale for number 7, you can say, I'm measuring my mother's weight. The units are pounds. Put that in observation. You can also put it in the data table, but you don't have to. If you put it in the observation section, you don't have to put it in the data table. But you got to put the unit somewhere, not online. Do not. You've got to enter your data. Down here at the bottom, nope. Where is it? It's under today's notes. At the bottom, it says report your data here. There's a website. You got to enter your data there. So you're going to create this lab. You're going to measure 6 things using 2 different measuring devices. You're going to do it in the technique that I taught you. You're going to upload your data. You're going to write a little lab report. It's not big. And the question is, what's the uncertainty of your measuring devices? So I expect at least those 2 answers.